two events are dependent if the outcome of the first event affects the outcome of the second event, so that the probability is changed. So I am going to have a look at Rudolph and his choice of colourful socks, but first of all, let's have a look at this box with some red and blue items in it. Now we can draw a tree diagram for this. So we have two options. We have our red and we have our blue. There are 4 red items out of a total of 7 and 3 blue items out of 7. Now what's going to happen this time is that once something is picked out, it is not going to be put back in, which means there are going to be less items in this box. So for the red, if a red has been picked out, there are now only 3 reds left. But as you've picked one out, there are now also only 6 left. So the probability of picking out a red after having picked a red out will now be 3/6. However, if you'd picked a red first and then to pick a blue, well, there are still 3 blue left, but there are only 6 left in that box. Let's go back to the start again. So we've already gone down the route of going to red. Let's have a look. Well, what if we picked out a blue first of all? Well, if we picked out a blue first of all, and then were to pick out a red, well, there are still 4 reds left, but there are only 6 in total. If we'd picked out a blue first, and now are going to pick out another blue, well, there are 2 blues left after having picked out 1 out of the 6 in total. So the probabilities then of picking a red and then a red, so that will be our 4/7 multiplied by the 3/6, which gives us 12 out of 42. The next one, so picking the red and then the blue, will give us 4/7 multiplied by 3/6, so it works out the same as the above, 12 out of 42. If, however, a blue is picked out first, followed by a red, then that would be 3/7 multiplied by 4/6, which again is 12 out of 42. And the last option would have been picking out a blue first, followed by a blue second, so that would have been 3 out of 7 multiplied by 2 out of 6, which is 6 out of 42. And we know that for all of those, to make sure that they are correct, one way of telling that is if they all add up to 1. So we have our 12 plus 12, 24, plus 12, 36, plus 6, 42. So we have 42 out of 42, which is the same as 1. Now, the probability of picking at least 1 red so that could be a red and then a blue. It could be a red and then a red, because that's at least one red. Or it could be a blue and then a red. So we're looking at these three probabilities here. So because we've got our three choices here, then we know it's going to be quite high, because it's quite likely to happen that we're going to get at least one red. So we're going to be adding these. So we've got 12 out of 42 plus another 12 out of 42 plus another 12 out of 42. So that's basically the same as 12 out of 42 multiplied by 3, which is our 36 out of 42. And of course we are aware of equivalent fractions, so we can simplify this one here. They're both in the 6 times table, so dividing them both by 6 we get 6/7. So going back to Rudolph then, with the problem with his socks here, well, he's going to choose a colour each day, and of course it goes into the wash because he likes to have clean socks. Now we could have a tree diagram, but that could start to get quite complicated, because we're going to end up having lots of branches, because we'd have one for orange, one for red, one for blue, and another one for green. And again, from each of those, so the next day, because he's already had his orange pair, there are then going to be more pairs coming off there. So the tree diagram could get a little bit complicated. We don't need that. Okay, so the probability of picking an orange pair and then picking a red pair, so that's a orange and red. Well, so the first time of picking an orange, there is one pair there out of 4. And then the next day comes along, so the orange is gone, we're left with 3 options. Okay, and means that we're going to multiply. There is one red pair out of 3 options. So therefore the probability of picking orange and then a red is going to be 1/12.